Okay, so this next lesson is about dot products or scalar products, depending on what you call it. People call it dot product because that's the symbol that's in between the two vectors is a dot. Or they call it a scalar product because it returns a scalar. So you can take a two-dimensional or three-dimensional vector and return one single real number with the dot product. There's a link on your worksheet where if you're interested to learn more specifically about what a dot product is, you can look at that. It's not something that would necessarily be assessed on your IB exam. Most of the questions will be phrased in a couple of these ways. So these first two formulas are the two different formulas that are given on your formula sheet for the dot product. So you just take your vectors and you add, you multiply the rows and then add those products together. So V1 times, like you multiply the top two, V1 and W1, and then you add that to V2 times W2, etc., so on and so forth for however many dimensions the vector is. The second formula is just a different way of looking at it, where theta is the angle between them. Remember that those bars mean the magnitude. So that would be the magnitude of V times the magnitude of W times the cosine of theta, which if we were to rewrite that formula, this formula is also on your formula sheet. It gives you, if you solve for cosine theta, this allows you to find the angle between two vectors. So oftentimes in IB, they will ask you for the dot product. They'll ask you for the angle between the two vectors, or they'll often say if something is perpendicular. Now, if it's perpendicular, that means that the dot product has to be zero. So if the dot product is zero, we conclude that one of the vectors is the zero vector or that they're perpendicular. If it's less than zero, then the angle is obtuse. And if it's greater than zero, then the angle is acute. Here are the properties of the dot product or the scalar product. They're pretty common sense, except for maybe the last one, where the first one says that A dot B is the same thing as B dot A, which if you look back at your formula, it just means that the order doesn't matter. So this could be W1 times V1, and it would still give me the same answer because addition and multiplication are both commutative. So then the second one is just A dot A is the same thing as the magnitude squared, where if you plugged in the angle between them formula, this second formula, I guess you could do it for both of them. But this first one is the magnitude of A times the magnitude of A times the cosine of the angle between them. And since they're the same thing, there's no angle. So cosine of 0 is 1. So then you would just have magnitude of A times magnitude of A, which is magnitude of A squared. So both of these are things that you should be able to figure out just by trying it. So this third one is the distributive property, basically. So A dot B is the same thing as A dot the quantity of B plus C. You can just distribute it almost like multiplication. So you have A dot B plus A dot C. Now 4 is the only one that's a little bit less common sense. Or I mean, it still is, but you don't distribute the lambda, the coefficient, whatever's in front to both things. You just distribute it to one thing. It doesn't matter which A or B you distribute it to. You just have to distribute it to only one of them, not both. Okay, sorry. Last thing is an example problem. I chose yet again another example problem that's maybe a little bit more complicated, I guess, is the word. So let's move down, give ourselves a little bit more room maybe. Okay, so for this problem, the first thing it says is find the relationship between the real parameters lambda and mu, given that the vectors A and B are perpendicular. So this goes back to the part of our notes where we say that if something is perpendicular, the dot product is 0. So for part A, I'm going to say that A dot B equals 0. And then I'm going to go ahead and write that out. So A dot B would be 2 mu. I'm just multiplying across the top. plus negative 5 lambda equals 0. Okay, so that is a relationship between the two that shows that they're perpendicular. All right, which leads us to part B. Part B says find the two possible vectors A in part A, given that the magnitude of B is 13. So they told me that the magnitude of B equals 13. So now I'm going to use my magnitude formula. So that would be the square root of mu squared plus negative 5 squared. Make sure you have those parentheses in there, equals 13. And then I solve, I get mu squared plus 25 equals 169, mu squared equals 144. And then when you take the square root, you're going to have plus or minus, and that's where the two possible vectors come from. So mu is either going to be positive 12 or negative 12, but we're not done yet because I need to find vector A, and mu is a part of vector B. So I need to figure out what lambda is, but right up here, I gave an equation that has mu and lambda, so I can just plug it in up there and solve. Y'all should be able to do that algebra. So first plug in positive 12 for mu, and then plug in negative 12 for mu, and you should get two different answers, and those answers are, it would be 2 and 24/5 is the first option, and 2 and negative 24/5 is the second one. So those are your two A values, two vector A's. So that should be that. On Delta Math, you also have a worksheet. That worksheet includes 2 links, one with some more sample problems with solutions. There's no Delta Math on this specifically, so this was the closest thing I could find to Delta Math. And then an extra resource if you just want to learn more about what a dot product is. I'm also posting a vector packet on Google Classroom, and so you won't be able to answer all of the questions in that packet, but you can go ahead and start looking at them. They're more IB styled questions. Okay, awesome.